That's right. Good evening, madam. Presenter, Mutebi Stephen, the ID 2022 00759, year 2, semester 2, the campus, Shirumba campus. Yes, you give us an assignment about mobile computing technologies, and according to what I researched, so that mobile computing is the technology that allows users to connect and transmit data, audio, voice, and video from one device to another without being tethered to a stationary area with a cabling and wires. So tethering is about connecting, physical connection. So when they say without being tethered to a stationary area with cabling or wireless. So mobile computing technologies, they are generally have evolutions, and the evolutions start from the 1G up to the current one called 5G. In 1987, GridPad was introduced as the first mobile tablet device. The following are the devices supporting mobile computing technologies. We have the smartphone, the tablets, the laptops, the wearable devices. We can have the smartwatches, and so on. So, in the assignment, in reference to the assignment you give us, we have to look on Bluetooth, Wi-Fi, Zigbee, GSM, mobile IP technology, wireless ATM technologies, the J2ME and J2EE, the iMode, the SMS, the WAP, and the GSMS gateway. So, when I start with the Bluetooth is the low-cost, low-power radio frequency technology for short-range communications. It can be used to replace the cable connecting portable, fixed electronic devices, build ad hoc networks, or provide data voice access points. Bluetooth technology allows devices to communicate with each other without cables or wires. Bluetooth relies on short-range radio frequency, and any device that incorporates the technology can communicate as long as it is within the required distance. That means the required distance. The technology is often used to allow two different types of devices to communicate with each other. It is an electronics standard, which means that manufacturers that want to introduce this feature have to incorporate specific requirements into their electronic devices. These specifications ensure that the device can recognize and interact with other devices that use Bluetooth technology. That means they should install some devices in their devices of which they are manufacturing, such that Bluetooth is compatible on their devices as on others. So many personal electronic devices, that is the PDs, use Bluetooth technology. For example, you may be able to operate your computer with a wireless keyboard, with a wireless mouse, or use a wireless headset to talk on your mobile phone. We have the earbuds or the earpods. They use Bluetooth. Bluetooth simply follows the principle of transmitting and receiving data using radio waves. It can be paired with the other devices which has also Bluetooth, but it should be within the estimated communication range to connect. So that is all about Bluetooth. When we go to the next slide, talking about Wi-Fi. Wi-Fi network is simply an internet connection that is shared with multiple devices in a home or a business via a wireless router. The router is connected directly to your internet modem and acts as a hub to broadcast the internet signal to all your Wi-Fi enabled devices. So all devices that have a Wi-Fi enabled or which are enabled to access Wi-Fi, they can use that Wi-Fi network through the wireless router. This gives you a flexibility to stay connected to the internet as long as you are within your network coverage area, as it is at the campus. We have many Wi-Fi access points where we can get internet access through the Wi-Fi points. So Wi-Fi uses radio waves to transmit data from your wireless router to your Wi-Fi enabled device. That is what Wi-Fi uses. It uses radio waves to transmit data from your wireless router to your Wi-Fi enabled device, like your TV, smartphone, tablet, and computer, and so on. Because they communicate with each other over airwaves, your devices and personal information can become vulnerable to hackers. That is cyber insecurity. So cyber attacks and other threats, they are inclusive when you're using Wi-Fi. In most cases, when you're using an open Wi-Fi which has no password, it is very, very, very common to be attacked by or to be a victim for cyber attacks. This is especially true when you connect to a public Wi-Fi network at places like coffee shop or airport. That's what I talked about. They are always open Wi-Fi. So when possible, it is best to connect to a wireless network that is password protected or personal hotspot. That is when you use your computer. You activate a hotspot on your computer and you get internet access on your phone. That is when you have a game in your computer, either an Ethernet cable. That's when you can have, or that's when you can create a hotspot. So, another one is about ZigBee. ZigBee is a standard-based wireless technology developed to enable low-cost, low-power wireless machine-to-machine (M2M) and Internet of Things (IoT) networks. ZigBee is for low data rate, low power application, and is an open standard. These technologies are designed to consume low power and to be purchased at or to be built at a low cost. Because we saw that on Bluetooth, it is also a low cost and low power consuming application or technology. So, as we know that ZigBee is the personal area network of task group 4. So it is based on IEEE 802.15.4 and it is created by ZigBee Alliance. General characteristics of ZigBee standard: it is low power consumption, low data rate, that is from 20 to 250 kilobits per second, short range, that is 75 to 100 meters, network join time, it takes over 30 microseconds to join that network, so it is very fast. So supports small advanced networks up to 65,000 devices, that is 240 devices practically. So low cost of products and cheap implementation, that is open source protocol. Extremely low duty cycle. It requires less supervision. So we are finishing the GSM, so and we are moving and we are heading to the mobile IP technology. The mobile IP technology is a communication protocol created by extending internet protocol that allows the users to move from one network to another with the same IP address without changing the IP address of which the user had on the previous network. So it ensures that the communication will continue without the user's sessions or connections being dropped. So that means the user will continue to have the search history, the cookies whenever he moves to another network. So the terminologies we have here, we have the mobile node, the MN is the handheld communication device that the user carries, that is a cell phone. The home network is the network to which the mobile node originally belongs to as per its assigned IP address. The home agent is a router in a home network to which the mobile node was originally connected. So the home address is the permanent IP address assigned to a mobile node within its home network. So we have the wireless ATM technology. This type of ATM, and we know ATM is the asynchronous transfer mode. So network was designed to offer high-speed mobile communications. Similar to other wireless technologies, the ATM cells are broadcasted from one base station and transmitted to mobile terminals where an ATM switch performs the mobility functions, mobility movement from one place to another. So wireless ATM, that is the WATM, is a wireless access network with an ATM core. And here we have the VO. The VO ATM stands for the voice over asynchronous transfer mode, and it is the protocol that allows the transmission of video, voice, and data packets via an ATM network. The IP protocol is connectionless, while the ATM network is a connection-oriented technology. So we move to the J2ME and the J2EE. So we start with the J2ME, Java Platform for Micro Edition. That is the abbreviation, as well as the J2ME, abbreviated from the Java Platform Micro Edition. This version of Java is mainly concentrated for the applications running on embedded systems. Those are the mobiles and small devices, which was a constraint before its development. So Java 2 Micro Edition was a constraint before its development. So constraints included limited processing power, battery limitation, small display, and so on. Also, the Java 2 ME apps help in using web compression technologies, which in turn reduce network usage and hence cheap internet accessibility. The basic aim of this edition was to work on mobiles, wireless devices, set-top boxes. All Nokia phones, which use Symbian operating systems, use this technology. So most of the apps involved for the phones prior to smartphones were built on Java 2 Micro Edition platform only. So the Java 2 Enterprise Edition, abbreviated as J2EE. The enterprise version of Java has a much larger usage of Java, like development of web services, networking, server-side scripting, and other various web-based applications. Java 2 Enterprise Edition is a communication-driven edition, i.e., there is a lot of continuous contribution from industry experts, Java developers, and other open source organizations. Java 2EE uses many components of Java 2 SE, as well as has many new features of its own, like subjects, Java Beans, Java Message Services. They adding a whole new functionalities to the language. The Java 2E Enterprise Edition uses HTML, CSS, JavaScript, etc. so as to create web pages and web services. It also one of the most widely accepted web development standards So when we go to the I mode, the information mode, this is abbreviated as the I mode. The internet mode is a micro browser technology that supports text, graphics, audio, and video for web access over the Japanese cellular network. So it was introduced by a team led by Mari Mustanaga in February 1999 at NTT Docomo. So the I mode system has the following three major components: the new transmission system, the new handset, the new language for web page design. So, and in that, the transmission system is made up of two separate networks, namely the existing circuit switched mobile phone network and the new packet switched network constructed especially for the I mode service. So, the voice mode makes use of the circuit switched network and its bill is charged on per minute basis. The I mode makes use of the packet switched network and it is always on. There is no billing for connect time in I mode. Instead, there is a charge for each packet being sent. So they charge for on the packet being sent basis. There's SMS. So when you look at the SMS, it is the short message service, commonly referred to as the text messaging. Texting, it is common to a variety of devices on smartphones, on our portable cellular phones, and it is a service for sending short messages of up to 160 characters. That is 224 characters limit if using a 5-bit mode. So to mobile devices, including cellular phones and smartphones. This 160 character limit was eventually decided upon by Friedhelm Hildebrand, who observed and tested the typical number of characters in the average sentence, combined with the compromise on the available bandwidth at the time. Nowadays, bandwidth isn't so much of the concern, and we can easily send messages back to back and recompile them on the receiving end. Long SMS messages have been around for many years, allowing for back-to-back SMS messages to be combined into long messages. So they send parts of messages and they are recombined at the receiving end. So when we go to the WAP, the Wireless Application Protocol, WAP was conceived in 1997 by Ericsson and Motorola. Those are mobile manufacturing company. They manufactured phones earlier before. That is, we had the Motorola phones, the Ericsson CyberShot phones. It allows other mobile phones to access the internet through. So it allowed the other mobile phones to access internet through a WAP gateway. The WAP gateway identifies the device connecting to the internet and can format the content to match the device's screen size and type. So they can recognize that this is a laptop and they format the size, the size of the content to match the device's screen, whether you're on MTN capability, whether you're on a smartphone, you're on a laptop, you're on a desktop, whatever the case, they are there to condense that content to fit that size. So the WAP has several limitations, including the low bandwidth, the high latency, the small displays on mobile devices, the slow processors, the slow speed and data transfer via mobile networks. So that's all about the WAP. When we go to the GSM, it's the Global System for Mobile Communication Gateway. The gateway is a device that connects GSM network to a different network or to another GSM network. So it is like a gate, a main gate. You move from a main node, you enter into a main gate which connects you to your home, to a feeder road towards your home. So it can also be used to route fixed line calls over a mobile network. So GSM gateway can contain one or more SIM cards from different wireless networks. they use a SIM card to connect to a cellular tower and convert the cellular connection to SIP. The gateway then provides the connection as a trunk to a voice over internet protocol. The number of SIM cards a gateway can hold determines how many calls can be made. So the GSM gateway allows businesses to make and receive calls using GSM networks. They convert incoming and outgoing calls from voice over internet protocol to a global system for mobile communication and vice versa. So, in conclusion, we have the considerations when choosing a GSM gateway. The API options. A good server provider will offer a variety of API options, including as unsynchronized and synchronized options, network coverage. Consider how the messages will be delivered and if the service is reliable. User-friendly interface. A feature-rich platform is a goal, but it should also be easy to operate. So that's what I collected according to the assignment. 18 slides, as you can see. So I beg to sign out.